The report ice algal communities in the Chukchi and Beaufort Seas in spring and early summer, composition, distribution, and coupling with phytoplankton assemblages, will be presented by Edgar Villarreal. Voiced over a text-to-speech because he has performance anxiety. The questions the report asked are: how do ice algal communities bloom? What is the role of ice algae in under-ice bloom development? The hypothesis is that sea ice algae can seed water column phytoplankton blooms in the Chukchi Sea. What we know is that phytoplankton are found deeper in the water column, underneath the icescape, and blooms later in the summer. Ice algae grow right underneath the ice sheet and seeds, spores, when the ice melts, later in the season. The objectives are to know environmental factors influencing late spring and early summer ice algal community distributions and to measure the maximum potential for ice algae to seed down to the water column with massive phytoplankton. To test the predictions that ice algal communities were going to spore where deeper in the column where phytoplankton are, they took 37 ice sheet samples and water samples at different depths of the water column and ice sheets throughout the Chukchi Sea. Also, sampling was collected from mid-May to late July from 2010, 2011 and 2014, when it was possible to observe. The ice during the spring were compared during the summer for its light penetration. Special sensor microwave imager data obtained from the National Snow and Ice Data Center were used to quantify sea ice concentrations. This was determined when ice sheets melt at sampling location spots throughout the year. Snow depth was measured with the ice core samples. To test the ice algal, they added a filtered water solution to reduce osmotic shock from the ice melting. The water column samples and ice slushy samples were collected to measure the nitrate, silicate, phosphate, and ammonium nutrient concentrations. How much light was going through the ice was measured using a hyperspectral radiometer system. Chlorophyll A was measured to quantify the ice algal and phytoplankton biomass. The results were as followed. There was no relationship between ice thickness and snow thickness. The melting rate was slightly delayed in the north and only one sample has shown advanced melting. The only nitrate was lower than expected. Chlorophyll was ice algal was high in spring than summer for ice algae, as expected. Chlorophyll and in phytoplankton were lower in spring and higher in summer, as expected. However, the light penetration under the ice was higher than previous studies. This was because of the snow inches have been lower than the year before due to climate change. The discussion concluded that the results supported the hypothesis. There was seeding down in the water column when the spring turns into summer. This is when the phytoplankton blooms in the summer. There have to be further studies made to understand why. What was amazing that the amount of light penetrated through the ice was double the amount from previous studies. Even though the melting rate was the same years before, the reduction of snow resulting in more light penetrating through the ice. The ice algae were not as sensitive as shown from previous studies and acclaimed over the years.